Here is my first video effort trying to demonstrate how to calculate probabilities associated with normally distributed data models. I'm going to use this homework packet as the demonstration. The first question of the homework packet, which as I promised I'd use as a demonstration. Where am I getting this packet? When I go to an internet and here as you can see, I'm logging into MyRCC, logging into our class. I click on the coursework page. It takes me to the next homework assignment, which for us is this homework assignment. I click on it, and in the assignment description, as I scroll down, one of the parts of the assignment includes practicing normal distribution probabilities. This is the packet distributed in our last class. The packet is also available here. When you click on this link, it will open up, and I opened it up here. So I opened it up here, and this is just the first page. You can see question 1. If I scroll down, question 2, question 3. So scrolling back up, question 1, as promised, I would demonstrate how to answer these two questions, part A and B. Again, how to calculate probabilities from normally distributed data. So here is the workspace that I'm going to use. Again, I'm using this file. It's unfortunately a little stretched out, but just a few notes before I get started. I want to emphasize first of all that this chapter 3, this is incorrect for our textbook. For our textbook, it's chapter 4. So again, normal distribution probabilities. That's covered in chapter 4, not chapter 3. And also you can see there are a lot of buttons on both sides of the screen. Unfortunately, we'll have to do our best to ignore these. I might have to push buttons occasionally, but for this screen, I'm going to do my best to focus here on the white space and what is written here. So for any probability question, as always, I begin any problem, probability or not, I begin any problem with reading the question carefully and taking some notes. So I'm going to read the question out loud. If you have had the opportunity to open your packet, you're welcome to follow along, or if you are still trying to open the packet, taking it out, then by all means use this time to take out the packet. Here I go. Question 1. For low birth weight, the University of Maryland Medical Center considers low birth weight to be those that are less than 5.5 pounds, or 2,495 grams. Data suggests that birth weights are normally distributed with a mean of 3,152 grams and a standard deviation of 693.4 grams. All right, information. So then, part A, if a birth weight is randomly selected, if a baby's birth weight is randomly selected, what is the probability that that baby will have a low birth weight? Okay, and so I remind myself that if I'm being asked to find what is the probability that a baby has a low birth weight, that I'm going to be needing to use my steps for probabilities, my steps for normal probabilities. So, for example, I just pull it up here, take out my notes however I want to. I remind myself that the steps for finding probabilities starts by drawing a curve and labeling points. Well, what do I mean when I say draw a curve? As we all know, that starts with drawing a straight line, if you will. This is going to be the world's most interesting curve. Oh my goodness. So, again, drawing a curve and labeling the points that are on the curve, meaning I have to at least start and figure out for myself where is the center of this data. where is the center of this data? And then once I find out, if you will, where is the center of this data, I also have to understand how spread out is the data from the center. Well, because I'm told that the birth weights are normally distributed and have this mean and this standard deviation, I automatically can draw more points. I can remind myself that, oh, this line represents for myself all of the possible birth weights. If I were to look at birth weights, infinitely small birth weights going that way, infinitely large birth weights going this way, then what would be the smallest birth weights? What would be the biggest birth weights? Well, the center of all birth weights, the average birth weight would be 3,152 grams, would be 3,000. Let's type that in, 3,152 grams. 3,152 grams, 3,100.0 grams, that's fine. So that would be the center of whatever histogram is made. I'm doing this to represent the bars. Whatever histogram is made from using a lot of babies measured and their birth weights, creating a histogram, and then drawing a curve over that histogram. Whatever that histogram would be created, since I'm told that the birth weights are normally distributed, that means that it will be a bell-shaped curve, symmetric, with the center around the number that's given as the mean. And the standard deviation will tell us also how many, I guess you could say, how many numbers have to be in between, a line like this and a line like this. Obviously, if we think back, we can remember that normally distributed data extends almost 99.7% of all the data extends within 3 standard deviations away from the center. 1, 2, 3 standard deviations away from the center. This side is a little lopsided. There. To describe for myself that almost all of the data should be within 1, 2, 3 standard deviations away from the center. And what will this number have to be? Well, that depends on this number, using this number. But I'll continue with making this curve, just noticing that the first step that I need to do is drawing this curve, and then labeling all the points. So I've started drawing the curve with this shape and started to label at least one of the points on this curve. I'm going to change windows. You see, I've taken more steps to draw this curve, as we can see from over here. Here's a different version of my curve. Again, I use the fact that the mean, I'm told that the mean is, where's my cursor? I'm told that the mean is this many kilograms and the standard deviation is grams. It's this many grams, and so using that knowledge, say to myself, okay, all the baby birth weights in a histogram, here would be the center, the mean, here's the center. And then if I were to take this 693.4, if I were to take that 693.4 and add it or subtract it from this mean, I will know what the next numbers are here and here. I will know what the next key markers are along the spectrum, if you will, of all the baby birth weights. So again, I'm trying to answer the question of what is the probability that a baby will have a low birth weight when I'm told exactly what a low birth weight means. A low birth weight here is considered to be the babies that have less than 2,495 grams. And to find that type of probability, the first thing that I need to do is, again, draw the curve, which now I've done, and label some key points. Well, I've almost labeled all of the key points. What point am I missing? Well, I'm missing this idea here that I'm interested in babies that weigh, here's my other hint, weigh less than, but babies that weigh and have something to do with this 2,495 grams. So, since it has to do with this 2,495 grams, I'm also going to need to display this number along the line, the spectrum, all of the possible baby birth weights. I'm going to want to know where that number falls. So where is it along here? If this is the smallest amount that a baby would weigh and there's a biggest number that the baby would weigh, where would we expect to see a baby that weighs 2,495 grams? What would we expect to have a baby that weighs? It would be somewhere between 2,458.6 grams, 2,458.6, and 3,100. 2,495 is definitely between 2,458 and 3,152. So I'm interested to know, I'm interested to know some point that's right around here. Right around here, I'm interested to know that point right around there. That would be a place where you would expect to see, the number 2,495. You'd expect to see the number 2,495 kind of in there. 2,495. You expect to see it kind of in there, in between 2,458 and 3,152. So again, I'm interested to know what's the probability that a baby has a low birth weight. Step 1, draw the curve and label the points. Now I've labeled all points because labeling all the points also includes the point that I'm interested in, the 2,495 right here. I'm also interested to know, if you will, probabilities, I should say. If you're interested to know about probabilities, we're interested to know what proportion of all of this area, all of this area inside of this bell-shaped curve and the flat line, what proportion of that area is less than 2,495, which proportion of the babies would have this low birth weight, less than 2,495. So, what proportion of all of this area, kind of section it off like this, section it off like that. So what proportion of all of this area section it off, what proportion of all of the area under this curve would be below 2,495, certainly smaller than 2,495, moving to the left, not to the right. And so what proportion of all that white space is going to be having numbers less than 2,495? Well, that's why the next step, if you will, here is shade that area that I'm interested in. I'm kind of interested in this area right in here, so I'm going to just shade it in a little bit. Shade in. I want to know what percentage of all of the area, meaning of all of the space between the curve and the flat line, what proportion is below 2,495? So I've now had a chance to do step 1, draw the curve, shade the area, draw the curve, label the points, and now also shading that area that I'm interested in. Great. Now the next step is clearly to answer the question. Finding that probability is the same thing as finding the area under the curve in that shaded space. So there are 3 ways to find that probability. We've talked about, basically, in passing, I've talked about using a normal table, but I'm saying let's skip that for now. So to find the probability, we can use the 68, 95, 99.7% rule, or we can use technology. Unfortunately, we can't use this rule. We cannot use this rule here. We can't use this rule because this 68, 95, 99.7% rule only applies for numbers that fall exactly on these key 7 points, these 7 red lines. Those are key numbers for the baby weights here that tell us areas of the curve, percentages of the curve probabilities related to that data. Unfortunately, 2495 doesn't land on any of the 7 red lines. It's in between 2 of the red lines. 2495 is not on one of these key 7 markers, so we can't use the 68, 95. We can't use that rule either. But we can use technology. And when I say technology, there are many different ways that you can use technology. I'm going to focus on one of which is my favorite. I mean, technology could mean any sort of available resource for calculating areas under this curve. There are many on the internet. Graphing calculators also, and 2 variable statistics calculators also can help you to do that. But I'm going to show you my, if you will, favorite tools, one of my favorite tools, which is called the normal distribution calculator, that's made by Online Statbook. Why is it one of my favorite? It's because it comes with the ability to make a visual, to visualize this same picture that I'm using here, visualize the distribution, the data model. So to access this website, again, we're trying to find the probability, and we're trying to do it using technology. I'm going to show you how to find it using the Online Statbook. To find it with, obviously, an online resource, I have to open up a window. I have to go to some sort of, return here to my Google Chrome, some sort of internet browser. And I'm going to open up a new page, Google, for example. You can type directly into your search bar. I'm going to type in normal distribution calculator. In fact, that's all you have to do. Notice I've searched for it before. I click on normal distribution calculator, and the first link that appears is the one for onlinestatbook.com. So I type in normal distribution calculator, and the first link that appears. I click on that link. It opens me to a website. That is for calculating normal distributions. You can see that normal distribution title here, and below the calculator itself starts in here. And you can see that there are instructions here on the side how to use it. There are instructions on the right hand side how to use the calculator. Now I go back to my other page so that I can remind myself what are the mean and standard deviation, what are the parameters that I'm going to need to input into this calculator, because that's the first step in the instructions. Specify the mean and the standard deviation here and here. So when I return back to my page where I've read my information up here, over here as well, here I have my mean, my standard deviation. So I can return to my calculator, and I can specify the mean and the standard deviation. Specify the mean as 3152. You can include the 0.0 or not, it's your choice. 3152, and look, my picture is already starting to change. This is why I like this calculator, because it can help you double check the work that you've been doing by writing a sketch by hand. So as you can see, I put the mean and the standard deviation, I double check that they're correct, and automatically I have these extra numbers, all of which do, when I look back at my picture, all of which do match the picture that I've been drawing, do match this picture right in here. Alright, so I'm interested in looking at the birth weights below less than 2495. I'm interested in knowing birth weights, the proportion of all birth weights less than 2495. So when I go back to my calculator, I'm going to have to include this information. I'm going to have to include this fact, this less than 2495. And the picture will change. So when I go back to my online calculator, I see that there are 4 options: above, below, between, outside. 4 lines, 4 options. And looking again at the instructions, it says indicate whether you want to find the area above a certain value, below a certain value, between 2 values, or outside 2 values. Oh, great. So I'm interested in knowing below. Below 2 values. Again, less than 2495 is the same as below 2495. So I'm going to change that number that's written there to the number I'm interested in, below 2495. And notice I selected that circle. And so step 3 was indicate the values. That's what I did when I typed in the number 2495. You can already see the picture. And hit tab, return, or recalculate, and the area will be shaded, and the size of the area will be shown in the bottom. You can see down here the result, the area, the probability, is this number in here. If I want to click recalculate, then it might show up again. And if I zoom in a little bit on this window, if I zoom in, if I can zoom in, if I zoom in, there we go, if I zoom in some more, you can see, I'll scroll down, if I zoom in, the number is 0.1717. So that tells me, as I look back to this picture, that tells me that of all the area under my curve, the blue area, the area under the blue curve, oh, I'm so sorry, the area under the, let's go back to here, I need to see it again. Okay, it's told me that the area, the probability, is this number. That means for me that the area under the curve is 0.1717, that area below 2495. And as a percentage, not as a decimal, as a percentage, that's approximately 17%. 17%. So, the area under the curve is 0.1717 according to our calculator, or you could calculate it with a different type of calculator. I used the online calculator. It gave me this number. And once I've been able to do that, I've basically answered find the probability. Find the probability using technology. Great. I did, and I answered step 1, step 2, step 3. So my check marks. Now the only thing left to do, and the most important thing to do, the most important thing that really needs to be done, is that you interpret the number that you get. You interpret it in context. And that's what I'm doing here. When I type this, when I say the probability of having a baby with low birth weight is approximately 17%, that is me taking the number 0.1717, that's me taking this number and reminding myself, oh, what does that actually represent? Oh, it actually represents the idea that a baby, if you pulled a baby at random, given the past data that we've seen, that probability is approximately 7% chance. The probability that the low birth weight would happen is about 17% chance. So we've answered our question. If a birth weight's randomly selected, what's the chance that it is a low birth weight, where the criteria given to me about all babies is that they're normally distributed with a mean and a standard deviation is given. Step 1, draw the curve, label the points. Step 2, shade the area that you're interested in. Step 3, find that probability. Here I use technology. And step 4, the most important part, is to interpret the answer you get. So, congratulations, we've survived our first half of the problem. We've answered part A of this question. Part A, check plus. And in a few minutes, I'll get back to part B. Thank you for your time.